Alright guys, so this is the second video, and this will cover um, um, much of Unit 2, the purpose of data types and strings, and then I will demo, I'm going to just demo a few different programs for you guys and how you go about writing those. So let's talk about primitive data types and strings. Okay, if I go in here, does a pretty good job with just a typical PowerPoint or Google slide, um, but let's talk about this real quick. Okay, so you got a bunch of different words, the different data types: byte, short, int, long, float, double, boolean, char. Okay, so all this goes back to is basic electronics. Okay, so if you turn an on switch on, it turns, the switch gets connected and power runs through the line and it turns on a light bulb. Okay, if you turn the switch off, it disconnects the connection and you don't have electricity passing through. And so what programmers started off doing was all data in your program or in your computers is broken down into a 1 into a 0. So let's look at this real quick. So binary. Okay. Let's look up binary converter. Okay. So let me see if I can find a binary to text. Okay. So if I put in the letter A, lowercase a, and convert that to binary, let's see what happens. Come on, convert. Is it going to convert? Uppercase A. It's binary to, okay, so how about this? Let's see this. Sorry. That's the binary input. Sorry, I needed to put ASCII in. Is it going to let me do this? Let's try a different one. I don't know why that's not working. Binary converter. Should get a few of them up here. Rapid tables. Text to binary. Okay, here we go. So if I type in A, say convert, that gives me an 8-digit character digit 011000001. So let me copy this and put this into a notepad file. So file, new, don't save, and control V. So that is a lowercase a. If I change it to an uppercase A and convert, I get alright, so notice in the 1, 2, third position, this is a 1 and this is a 0. So Java is case sensitive, meaning that uppercase letters and lowercase letters of the exact same letter are saved differently, okay? And so basically all your information is saved and it's stored as a 1 or a 0, okay? And they're 8 characters, all right? Now these things take up physical memory on the computer, okay? Which at one point in time in history, there wasn't a lot of physical storage, okay? That stuff was very expensive. And so what programmers did is they came up with different ways to store their information, okay? So in your brain, you could think of any number. You could think of like infinity. Well, infinity, if we came up with a number really, really, really large, in theory, it could take up the entire memory of your computer. All right, and but with programming, what they did is they said, okay, a byte can hold numbers negative 128 to 127, okay? A short can hold negative 32,768 to positive, okay? So then we got ints, longs, floats, and doubles. For numeric data, you probably only need ints and doubles. Those are the only ones you need to remember. Ints hold whole numbers, all right? Doubles hold decimal values, okay? The other ones, quickly I can go through these, but you're going to want to look at them. The other ones are char. They hold single characters in single quotes. Okay, here's, char gender. If you're filling out a form, you put an F or an M in for male or female. You've got boolean, which stores true or false. So is adult is true, or is adult is false. String isn't actually a primitive data type. I'll talk about that later on, and strings become very important in AP. But in intro, it's just I've got a string name, and name is set to whatever value I store in it, and it's in double quotes. Okay, strings are actually objects, and you could store whatever you want. You could if you would want to, you could create a string value called dictionary, and you could set it equal to and then put every single definition in the dictionary if you wanted to, and it would get stored in your dictionary variable. Okay. So that's just kind of a brief description of what these are, but I think it'll be better if I just demo so you can see how they work. Okay. And we'll just get more practice writing program and code, okay? So, what I'm starting to give an intro to every single program that I demo is something that looks kind of like this, all right? You get a problem description, okay? Lots of wordy English words, okay? Remember, the English language is really wordy, and it's really descriptive. And so what we want to do, and what I hope to do, is help students easily be able to decipher what's important in these problem descriptions so that they can turn into machine language pretty easy. And so what I've done is I've basically built this table right here. Now, we're not going to use this last cell in this table because we're not there yet. That's not until later on in the semester. But we can fill out these first three pretty easy, okay? So, first of all, we got to read the problem description and determine what are we trying to do, okay? Okay, so it says write a program that declares the following: string variable named name, an int variable named age, a double variable named annual pay. Store your age, name, and desired annual income as literals in these variables. The program should display these values on the screen in a manner similar to the following: my name is Joe Mahoney, my age is 26, and I hope to earn $100,000 per year. So let's get this drawing tool out here, and okay, sketch screen. Okay, so what is this program trying to do? It looks like it's trying to display your name, your age, and whatever income you're trying to make or whatever. Okay, so what are we trying to do? Display name, age, and income. Okay, and up here, this is kind of important: name, age, annual income. All right, I'll talk about that in a second. Next thing we do is We circle nouns and underline verbs. Nouns and verbs are both important words in programming, and I'll explain why here in a second. But go through here, right? So we're circling nouns and underline verbs. String is a noun. Variable is a noun. Name, int, variable, age, double variable. A double is a thing. Okay. Whoops, I'm sorry, I screwed something up. Right is not a noun. Where's my erase? Right is a, okay, write is a verb, okay? So write a program that declares the following. Okay, store is a verb. Age, name, annual income. These variables. Program. Display these variables on the screen. Values is a, okay. They manage similar to the following. Okay, so we would list these out then. So program, we got write, we've got display. What else is there? Okay, so then we got declares. Okay, name, age, income. Name is a string. Okay, so here's, I gotta actually, let's see here if I can click on this. Nope, I can't save it. I gotta close it. So here's what I gotta do. I gotta scroll down and how am I gonna do this? I do this view. I want this at, let's say, 75%. Okay. All right. So just remember, guys, that this is the nouns up here. Okay, let me go back in. Sketchpad, notepad. All right, so just remember, these are nouns. These are verbs. Okay, so first of all, nouns will act as our class name or our variables, and verbs will act as our methods. This will be helpful here in a minute. So I think there was write, and display. This one had a bunch. It was like program. The problem with what I'm going to tell you, it's not a perfect science. There are certain words that are descriptive to the US or to the English language that we are not going to use, and so like the word program, we're not going to use it because it's going to be in every single program. You're going to have to write a program every single time, so I'm just crossing those out, okay? But we are going to display name, age, and income. So this will become a method that we're going to use, all right? Now other ones in here were age, name, and income, right? And this was an int, because an age is a whole number. A name will be a string, and we'll say income is a double, okay? From here, we can write out ourselves a nice little model. So the program, I can't move it up because I'm on my screen pad. I'm not actually on the Word document. But I always tell kids, so the program was called name, age, income. And it was in bold. So I always tell kids, okay, whatever's in bold at the top of your program description, this is going to be your class name. So we're going to call our class name, age, income. And this helps because when we're creating our program in NetBeans, this will be the class. It will be main name, age, income for our first file, and then name, age, income. So we have an int age, a string name, and a double, that's hard writing with this pen, double income. Okay, and we'll have a method called display name, age, income. Okay, and so basically our UML model now, we should be able to write our program directly from this and do what we want to do with it. Okay, so now basically what I did is I turned in that really wordy description that, you know, a lot of kids do not like word problems, and I get that. So what I did is I turned that word problem into this, and now you should be able to program almost your entire program from this UML model. Okay, so and I'm not going to be able to jump back here because the minute I close this I'm going to lose it, but if we open up NetBeans here, just remember, come back to this in the video and open up your own NetBeans and then practice this. Okay, so if I open up my own NetBeans, okay, I can say file, new project, next. We'll call this one main name, age, income. Okay, where are we at here? Main name in box. Okay, so then we need main name, age, income. I open this up. Okay, open this up, right click, new Java class, and call it name, age, income. Okay, so here's my class, name, age, income. Remember don't ever forget your skeleton if you're struggling with this. We got section A is the class name, B is the object name, C is the class name, D is the object name, E is our method name. Okay, and then you can go back and look at the UML model, but see what I'm going to do. I've got name, age, income. My name, age, income equals new name, age, income. And then my name, age, income we'll call a method called display name, age, income. Okay, there's an error here, it doesn't exist, so we go into here and say public void display name, age, income. Okay, and now up here between where the class starts and the method start, we have to define our variables. So we could say int age, string name, and double income. Okay, now what I just did there, these are variables, okay? And a variable can change, all right? And later on when we start making dynamic programs, our variables will change. But right now, we got to assign those variables to something. And declaring variables, there's three things your computer program will always do. First thing, you always have to declare your variables. Second thing, you assign your variables. And third thing, you display your variables. Okay? So declaring the variables tells the compiler, hey compiler, I'm using this word age, and it's going to store whole numbers, int information, whole numbers, okay? I'm using this variable name, it's a label called name, and it's going to store string information. I'm using this variable income, and it's going to store double information. Now, you can declare and assign a variable on one line, just like I did up here. Okay, or you could, you could just do it right here. Okay, just kind of depends on what you're doing, all right? And my income that I would hope to earn is $999,999.99. Okay, that's a double. Okay, now I can't put a dollar sign in front of that. Remember, doubles just hold decimal places. I've seen kids try to put commas in there too, and that doesn't work. Okay, just numbers with decimal places. All right, and you don't even have to put decimal places. If you put that, it would automatically get saved as 0.0. Okay, but I'll put 0.99. Okay, and then all you're doing here is just displaying your name, age, income. So system.out.println. My name is, and then name. And what does it want me to say here? Name, age, income. What does it want me to say? My name is, okay, so comma, my age, okay, so comma, comma, my age is, how do I want to do this? My age is, notice, name, when we do this, name won't display. What's stored in name will display, because name is a variable. So this will say, my name is Mike Seeley, my age is 38. Okay, my age is 38. Okay, and what I'm doing is I'm doing string concatenation. The Latin root for concatenation is concat, meaning to bring together. So this is called string concatenation, all right? Whoops. And I hope to earn, this is where I'd have to put the dollar sign for my formatting, plus income. I think it's per year, right? Okay, I hope to earn that, plus per year. Okay, notice when I open a quote, I close it. If I do not do that, I get an error, okay? But I think I've done everything right, so let me run this one. My name is Mike Seeley, comma, my age is 38, and I hope to earn $999,999.99 per year. Maybe I'll put a period right there. Bam. All right, so let's recap this. I've demoed a few different strings, but I showed you where the Google Slides document is to go look at the different variable types. Okay, you'll want to read that whole document. I demoed for you how the format is for whenever you get a problem. Make sure you read it first and then decipher what you're trying to do, because you have to figure out the purpose of the program. Figure out the nouns and verbs, because the nouns end up becoming your class name and your variables, and your verbs become your methods, because your methods do something. Remember, verbs are going to be action words. So for everything we do right now, we're probably just going to display stuff, but that will change soon. Okay, and then you can create a quick UML model with the name of your program, the variables you're going to use, and the methods. And from that, we basically did everything. If you remember your skeleton, we did this, okay? When we created the program, we created our main name, age, income. That was the name of our program. Okay, right here. I told you in bold, name, age, annual income. Annual is descriptive, so I just put income. You could change it to annual income if you want. This is our class name, and I told you, okay, here are your variables, and here's your display name, age, income. So that's your UML model. If you could do that and not do any of this, if you could just do all this, what I told you, in intro, you're going to get pretty good points on your quizzes and tests. And then it's just kind of everything builds on itself, so they're just memorizing this kind of stuff, and then you're good. So anyway, watch this video, and I'll make the next video. It's going to be called Car Class, I think, but we'll go through another example, okay? And that's it.